In this video, I will show you how to find the determinant of a matrix and the inverse of a matrix. So we're going to dive right in because we're supposed to find our inverse, but in order to find our inverse, we need to also find the determinant. Because here's the thing, our inverse is going to equal 1 over the determinant of matrix R times the reverse negate matrix. Okay, now this phrase reverse negate, I made this up. This is not a formal mathematical expression. So I will explain what this is, but this is a Mr. Helpful Not Hurtful exclusive. You won't find this anywhere else. So based on the little definition that I'm setting up for you, you see that I need to do 1 over the determinant. That means I need to find the determinant before I do anything else. So let's do that. Let's find the determinant of matrix R. So the way you find the determinant of a 2 by 2 matrix, you simply do the down diagonal minus the up diagonal. Okay, so the down diagonal is like this, and then the up diagonal is like this. Okay, so if I do the down diagonal minus the up diagonal, I'm going to have negative 12 minus, and then I've got negative 7. Okay, so when I say down diagonal, hopefully you can see that I mean I multiply the down diagonal and I multiply the up diagonal, and then I subtract those two. So negative 12 minus negative 7. Now, when you subtract a negative number, you must add. So this is really the same thing as negative 12 plus 7. So that's why the determinant is going to be negative 5. By the way, if the determinant is 0, then there is no inverse. Also, to have an inverse, it has to be a square matrix in the first place, like 2 by 2, 3 by 3, etc. So anyway, now that we have the determinant, we can go on with my little formula. So our inverse is going to equal 1 over negative 5, okay, the reciprocal of the determinant, times the reverse negate matrix. So here's what I mean by that. I'm still looking at the down diagonal and the up diagonal, but I'm going to reverse the down diagonal and negate the up diagonal. Remember the cha-cha slide that used to, there was a part where they used to go reverse, 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 reverse. So think of that, except say reverse negate, reverse negate. So that might help you remember. I know it's a little silly. It helps me. So if I reverse the down diagonal, that's going to be 6, negative 2. Now if I negate the up diagonal, that means just change the sign. So I'm not moving anything, but the positive 1 will become negative, and the negative 7 will become positive. So that's what I mean by reverse negate. So that's what this means. So now I just have to do this, and I'll have my inverse. Just remember, multiplying by 1/5 or negative 1/5 is the same thing as dividing by negative 5. So I'm really just dividing each of these by negative 5. So what am I going to get? So this is going to be negative 6/5 and negative 7/5. A negative divided by a negative is a positive. Okay, so that's going to be positive 1/5 and positive 2/5. And that's it. This is our inverse. Number 14, we are once again supposed to find an inverse if it exists. It's a square matrix, so that's a good start. If it has to be a square matrix in order to have an inverse. But also it's important that the determinant does not equal 0. So that's the first thing we have to do anyway, is find the determinant. So remember that the determinant of matrix T is going to be the down diagonal minus the up diagonal. Okay, the down diagonal minus the up diagonal. So the down diagonal, when I multiply, that's 12, and the up diagonal is 12. So that means the determinant of matrix T is 0. So that's not allowed if you're going to find the inverse, since part of finding the inverse is doing 1 over the determinant, and you can't divide by 0. So this cannot be 0 for the and have an inverse. So we're going to say there will be no inverse because the determinant of T equals 0. Alright, for number 15, we have to find the determinant of a matrix, but the matrix is a 3 by 3 matrix. Okay, so how do I find the determinant of a 3 by 3 matrix? So we need to find the determinant of matrix B. So we can't just do down diagonal minus up diagonal like I normally would. So the first step is you have to pick a row. Normally I look for a row that has zeros and ones in it, because the calculations will be easier with smaller numbers. None of these rows have zeros and ones, so I might as well use the top row. So focus your eyes on the top row. The method I'm about to do is called Cofactor Expansion. Okay, and I think these numbers are the cofactors. So I'm going to put them in front of a smaller matrix. So I'm going to have this 6, and I'm going to have this -4. Okay, and I'm leaving space for a matrix in here, and I'm going to have this 7. Alright, I'm putting each one in front of a 2 by 2 matrix. Now, next thing you have to worry about is the sign of these things. If you're dealing with the top row, the sign pattern goes like this: plus, minus, plus. Now, that doesn't mean that the first number is positive and the second number is negative and the third number is positive. It means, when I say plus, it means leave the sign whatever it is. Minus means change the sign, and plus means leave the sign whatever it is. So I'm going to keep these two the same because of the pluses. This minus tells me to change this to the opposite of what it is. So I'm going to change that to a +4 because of this. By the way, if I had picked the middle row, the sign pattern would have been minus, plus, minus, meaning change it, keep it, change it. And if I had chosen the bottom row, we would have gone back to plus, minus, plus again. Anyway, so these are my cofactors. Now, to find the 2 by 2 submatrix that goes next to these cofactors, you need to take it one cofactor at a time. So looking at the 6, cancel out the column that has the 6 in it. And then you can see the submatrix that is left. So the submatrix goes here: 5, 10, -2, and 9. Alright, see how I put straight lines around them instead of these type of brackets? That's because we are taking the determinant of these 2 by 2 matrices, and the straight lines mean take the determinant. Okay, anyway, let's move on to the next cofactor. So looking at the -4, we will cross out this column. All right, that leaves the submatrix 3, 10, 4, 9. Okay, now looking at the 7, we cancel out that column. So that leaves us with the submatrix 3, 5, 4, -2. All right, so now all we have to do is evaluate all of this. So I have 6 times. Now, the determinant of a 2 by 2 matrix, remember, is down diagonal minus up diagonal. So that's going to be 45 minus -20. All right, I'll come back to this in a moment. So then I have plus 4 times, again, down diagonal minus up diagonal. So 27 minus 40. Okay, we left this the same, so this is a plus. 7 times down diagonal minus up diagonal. So -6 minus 20. All right, so I just need to continue to evaluate this. Please don't forget, when you do minus and negative, this is addition. So inside of the parentheses, this is what you get. And now I'm just going to multiply these together. So this is what you get from the multiplication. And if you add all of these up, or subtract, you're going to get 156. So this is the determinant of the 3 by 3 matrix B. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.